Good morning. Thank you so much for joining this morning. And thanks, guys, for allowing me to speak. Jokes apart, this is Viswanatha Swamy. And here is the source code repository. You guys can grab in, and whenever you want, you guys can give that a shot. Uh, do a hands-on that. I'll put it in chat so that you guys will have access to this. Access to this one. So this is the session where we will be doing a simple or a mini project using Azure Durable Function. Okay, so my name is Viswanatha Swamy, but people call me Swamy. I work as an associate architect at AIS, and I'll be active in Twitter. I have LinkedIn also, but I don't be active there. But Twitter is the one where I'll be pretty much active. Vishipayyallore, that's my Twitter. You can see that here. This is my Twitter ID. I'll be active over here. So that's one thing. And this is my GitHub repository. Feel free to grab the source code from this speaker series, precisely this session. So I am still a learner, and apologize if I do any mistake. And most of my tech talks will be live session. It's like 0 slides and full on demo. So this will be the same. So what are we going to do today? So we'll go and see that what durable functions are and couple of patterns on that. And we'll see the solution map of fully baked in solution. First, we'll go through that and then we'll start hands-on. I mean, we'll recreate that. It's live. Even if it is failing, it will fail live. Okay, let's do that. And please fasten your seat belt. You have already boarded a express train. That being said, let's go and start a little bit of things I would like to show. I'll come here. I just have few of the Azure functions to show what Azure function chaining is, because we know that Azure function is a serverless computing. It's serverless, but there is a catch. What kind of app service plan, what kind of plan you have it for the Azure function will determine whether this is the this serverless function or you are capping it, because there are a couple plans. We'll see that in a moment. If I come in here to first 5-10 minutes, we'll speak verbally and then we'll go full on demo. But if you see that there is this Azure function and there'll be a lot of calls which will be going on, like output of one function will be accepted as an input to another function. So if I come into the live metrics here in application insights, you will see that there will be one function which will be dropping a message into the queue, and there will be another function which will read from the queue. You can see that one of those timer function every 5 seconds that drops a message into the queue. And whenever that drops a message into the queue, there is another Azure function which reads that from Azure queue storage. So you can see that live metrics, any dependency call, fail use, or whatever it's failing, you can track it over here. And the application map is the one which is very useful for us to go and see what is happening in that Azure function. So here there are a couple of things. As I told, the first Azure function will drop a message into the queue. The second Azure function picks up that particular message, processes it, and drops into the blob storage. Okay, we can dig deeper into this and go deep into the weeds, but just wanted to give a quick context, like what is Azure function chaining before we go ahead and discuss on Azure Durable Function. So in this Azure function chaining, we are going to do the similar thing, but 3 functions in Azure Durable Function. But someone can ask, Swamy, what is the difference? We can achieve the same functionality with these 3 individual stateless functions. The same thing. Yes, we can definitely achieve. But what if at all, like you are applying for a university? That's the step 1. You upload your document. Someone will review and put it to the stage 2 for approval of the headmaster or a principal, and he approves and you get this letter. Like there are 3 phases of this. Now, if we can replicate the same using individual stateless Azure functions. So you upload a document, one of the stateless Azure function picks it up, put it to a blob storage, and drops a message in the queue. And based on that queue, another Azure function will trigger, pick up that image from this blob storage and sends it to an approval. Someone can approve, or these kind of things go. What if something goes wrong anywhere? Maybe that could be the temporary blip or something. Even if the temporary blip, if that your record is missing or it's not getting further processed, and you will not be able to find until unless you dig deep into the weeds to find out what happened, the logs and other things. So just to avoid all these things, we will be able to use Azure Durable Function to create the similar functionality. This is one of the things. Okay, so now let's come to the Azure function. You can always, I suggest to use application insights, because this is a beautiful thing which gives us the application map is the one which we can depend on the live metrics when you are investigating an issue, when you're debugging an issue, when two of your teams are integrating a component and it's failing, then you can come in and see that why the dependency call is failing. Right. So now let's come back and set the foundation. What are we going to do today? Okay, so that's the one. Okay, so here let's come real quick and see that we know that just now we spoke about this. Azure Functions is a serverless until unless you are having a proper plan. We'll see that what serverless is. So what are the functions used for here? API, and you can do all these things. Let's quickly jump in to Azure Durable Function. So Durable Function is an extension of Azure Function where we can maintain the state. Okay, so we'll see that what these states are. Okay, so you have something known as orchestrator function and activity functions, which we will be creating shortly. And these are some of the patterns. You have function chaining. This is what we will be creating in next 1 hour. We will do an hands-on and we'll create not this hello world. This is like a hello world plus plus, and you have a fan in and fan out. Suppose you have multiple functions, you parallelly call those and get the output and drop it as an input to the another function. And async HTTP API, where you have a lot of heavy processing is happening, we can put it onto the work and get the status separately. And there's something known as a monitor, like a polling mechanism to see that did you complete, something like that. And human interaction is where you put it for approval and wait, and you can do an escalate or you can do an auto approval that based on this requirement. Okay, stateful entities aggregator is another one. Like this, there are multiple things, but at least if we are able to do even a single function, single mini project using this, I think it's like a 50% of the winning, right? And what else we need to discuss? Okay, a quick comparison. You can have this whether to choose an Azure function or whether to choose the web jobs. So you can see that these are the things which are available. So serverless app model and automatic scaling, this is available. And the web jobs doesn't have that one. And the supported language is this guy is winning. And if you see that Azure, we'll see that Azure Functions. Okay, hosting plans are pretty important. So see this, let's come in here. The consumption plan. The consumption plan scales automatically and you pay only for the seconds or milliseconds, whatever these people are charging. But this is the pure serverless. That means you're not blocking any server for this. It's purely based on the code which you execute, and for you'll be charged for that milliseconds or whatever is that. And if you have the premium plan and dedicated plan, that means you're going to pay X amount of price, maybe in rupees or dollars or whatever your local currency is, you'll pay that much. So that means whether you use a premium plan, whether you use a dedicated plan, that means there are fixed number of rates. Let's assume you have taken a premium plan and you're spending $1,000 every month, and your Azure function has got executed only 20 times in that month. And if you go by the consumption plan, that would have charged only $10 or $20, but in fact, you're paying premium plan for that. So it's like an overkill. So we need to understand this requirement, how many times this gets executed. So is it the consumption plan is the best thing to suit, or the premium or dedicated plan? You have to choose that. And we need to do a clear cut tech feasibility, or understand that what is best for the project and the customer. And the second thing is consumption plan is, if you have, if you're dropping more number of messages into the queue, that means it has to automatically add more number of instances to execute that and shrink whenever the messages are low. So that the scalability and the pricing, just keep at least these couple of things to on the table for us to decide which one to choose. Okay, so here it's like you choose premium plan when your function app runs continuously or nearly continuously. But here you said that scales automatically even during the period of high load. That means every minute we expect that there are only 2 to 3 messages in the queue. All of a sudden there are 30 messages in the queue. So it expands and contracts automatically. Okay. So supported language, application patterns, blah, 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 whatever is there, let's leave it there and we'll start. Just give me a minute. I want to show that this is a resource group, and this resource group has got one storage account and one application insights. We don't have anything. This is where we will play live, and this is the one which I already deployed. So let's keep it there. Let's come back over here to see how we execute this Azure functions. I think I have shown, I think I didn't show you guys the application map. There's an application map of the solution. So we have the Azure Durable Function, where we have the startup function, we have the activity functions, and we have the orchestrator. This is startup class for the dependency injection. And this is the HTTP functions. We moved some of the startup functions into this one. And we have weather utility lib and weather utility core. We have interfaces, entities, and those two. And let's see that. Let's recreate this every bit and piece we are going to recreate now. Let me execute it for 1 quick minute before we go further. Like if you come and hit this. Postman. Please post your queries. We can speak at the end of the session. The session might go till 50 minutes to 1 hour, and we can go on a Q&A once we start this. So this is what we are executing. This I just want to show you the fully baked in project, and we are coming to recreate. We are going to recreate this everything. So here you can see that there are multiple functions are there, and this is the starter function. So if I take in this one, HTTP localhost weather utility starter. So let's come in here. I might have something. Okay, it's all. Okay, it's not that. Okay, let's copy in from here. Let me close all these things because this is creating a lot of confusion. Don't save. Just give me 1 minute. Don't save. Okay, so now let's take this starter functions URL. I'll copy this and then put it over here. And then send. So I think it's a post method. I'm sorry. Right, that's a post method. So I need to pass in the object. Let me go here. That's a durable function. This is the one for that weather UT. So it expects an object that is some name we need to send in. So I send in the name. So it gives us these URLs. So these URLs means it has accepted this and it started triggering that function. Okay, durable function. So I can do click on this link and that link will give us a status whether what happened to this function which we sent in. So did it fail somewhere? So you can see that this is the input it received a GUID and a name, and then what was output? It said success, and the message is all is well, and it brought in some of the it did the calculation. So what does it do? So that's I just wanted to show you it how it runs as of today. We are going to recreate it. Just bear with me for 2 more minutes. I just would like to explain little bit things, and then we'll go deep into the weeds. Uh, so at this startup, so this is used for the dependency injection. So we have some of the services that we are doing a dependency injection, but we'll have a deep dive into that, how the service containers are built and how does the dependencies are approved or injected. We'll get into that. And there's something known as a HTTP function. This is a startup function. That means whenever you saw that the weather utility starter, this is a startup function and we'll create it everything from scratch. There'll not be anything. We'll create it from scratch, but I'll do a copy paste just to avoid me typing it. I don't want everyone to sleep while I'm typing. So I'll do a live. There'll be a little bit jokes from my side. I don't know the quality of the jokes, but to keep the session live, I try to do some jokes in between. So it receives the input, the request will come in and the request will be of this weather DTO. And once that is done, then we'll call the orchestrator function. So this will be the starter function, which is going to call the orchestrator function. So orchestrator function is the key guy who calls the multiple activity functions. So he calls the activity function one, gets the data, and that's the state, and then sends that as an input to function two, gets the state, and then give it to the another one and get the state. So before jumping deep into the weeds, we need to understand that event sourcing. Okay, so this guy maintains the event sourcing pattern. That means whenever we execute any Azure function, so what it does is it maintains the state of that. Okay, what function I have executed, till what state I have executed, where should I start it? So this guy will maintain the event sourcing state. So it knows that till what level we have executed. If you come and see this, every time it will come and hit this line and then it goes back to the blob storage. It finds out that did it execute this function, and yes, if it is yes, it will start from here. So we'll see that also in action. Okay, and there are three activity functions. The first activity function is here are the dependencies which are getting injected. We'll see that how it is getting injected. The weather data, first someone will go and get the weather data. Let's assume that it is coming from the weather.com or some other external services. We need to go get this weather data. And then for that, what we receive as part of the weather data, we'll go and calculate the Celsius to Fahrenheit. And that's another function. And then what we will do, we'll get the comfort index of that. That's the mini project which we are going to develop. Okay, without further delay, what we'll do is we'll start creating this and we will go deep into the weeds step by step. So let me open another instance of VS 2022. So this Visual Studio 2022 instance will start. Where should I place that? Let me come in here. I'll create a new folder called, because just to keep the same name, because that will help us using the source. So let's create this. We'll create a new project or a solution. and we'll go ahead with this Azure functions, or you can do like functions. Like you can see this is a template. Others are from AWS Lambda. For Azure functions, this is the function template. So you should see this here, or if you have used it recently, it shows it here, or you can do a search for function. You will see that over here, right? So we'll select this and click on next. And let me use the same naming convention just to avoid the confusion. What was the solution name? This one, utility. That's the name I have used. So let me use the same. I have to create a blank solution or something. Weather utility durable function. Okay, that's the name of this function come solution. So sorry for that. File, new, project, and let's select Azure and click on next. I use this. That's the name. And let me ensure that I'm placing in the right folder here in this source one. That's the project where we are dropping it. And I'm creating this function. So here you can see that we are using .NET 6 and we are using local emulator, and the authorization is at the function level. OK, now we can search for a durable function. OK, search for this durable function and then click on create. And that creates the basic Azure function, Azure durable function with the starter function as well as the durable function and activity function. So all these things will be there. Just let's give it a couple minutes, not couple minutes, few seconds for it to get the dependencies. You can see that. It's getting the dependencies. Let's do a build. OK. I think the path has become too very long. I'll close the solution. And instead what I do is I'll create right here. OK, I already created that. So I'll create source v2 because there's a limit of the path. It can't go more than that much length. So that's the issue. So let me create at a shorter length. It will not take much time for us. Let's do a create new Azure function and let me go and click on next. And let's give the path and come back and select the same name so that will help me copy paste the code while discussing. So that's an Azure function. Durable function we have selected and durable orchestrator and click on create. So we'll do step by step of everything. So first we'll understand first question. When we were creating this Azure function, I've shown you the resource group, which was pretty empty except this storage account. Why do we need storage account for? So we have to ask this first question. So when I come into the containers, you see that the container doesn't have anything except this logs. And you see that it doesn't have anything in file share. It doesn't have anything in queues. It doesn't have anything in table storage. OK, so at this point of time, we are using the local storage. So let's start probing deep into the weeds. So why do we need that? OK, for that first thing is we'll break the ice step by step. OK, first time, let's see here few things we have to focus. This is an orchestrator function. It does the job of calling the activity function. Okay. And this is an activity trigger. That's a triggered function. That means all the activities, it's part of the activity function, which does the job. Okay, this is the starter function. That means this is the first guy who will go and invoke this. Okay, that's the first guy who go and invoke that. So let me close this one and open the one which I did it in the V1 solution, but we'll keep that as an handy to, because I made some enhancement but forgot to check in the code. Okay, so we have come in here. So let's execute this. And before that, let's go and see what all the tables which it has got. So it has got my task hub and test hub namespace, test hub history, and weather utility hub. So let me execute this and see. There will be change in there. So we will see step by step. Once we deploy, we'll do a quick deployment also, and then we'll start seeing a few things there. Then we'll understand why do we need storage as part of developing this Azure functions. Okay, so it's booting up this durable Azure function. So this is a starter function. Let's copy this starter function and put it as part of this, because here we are supporting both get and post. So once we start that Azure function, that goes and executes this durable function. We'll put the debugger. Just bear with me for 20 more minutes. You have to bear with me before we put the debugger and see the event sourcing. So here we are getting it. Hello from Tokyo, hello from Seattle, and hello from London. That's cool. Now we need to come and see that what happened behind the scenes in the storage explorer. I do a refresh. So let's expose this one. So maybe either the my task hub or this one. Let's see this history. One out of this will have this. What's the date today? Then it is this one. Also I can delete everything. Yep. See this? Orchestrator function. So there will be a table in the storage that maintains this entire history, what happened. So what inputs has gone when you invoke this one. See that? You slowly come in. We didn't send any input. And what is an orchestrator instance? And was the task schedule? What was that? London, Seattle. See that? Everything is getting tracked here. So that's how it knows that what functions has been executed, what was not executed. It knows everything. So let me do a cleanup of this so that we can put a debugger and we can see that those entries. I want to remove some of those entries. I don't know how to. Oh, I think this is the best way to delete. Let's delete it so that we'll see. We'll put a debugger and oh God. Or else anyway, we'll do a reverse instead of we doing this cleanup thing. Anyway, we have the timestamp. Let's do the reverse. Let's put the debugger. Now let's understand a little bit more. I'll come in here and we'll remove all these things, folks. Just bear with me. But I want us to understand the fundamentals or internals, what is happening deep in the weeds. Okay, come in here. And once again, I'll come and execute this function. I'll execute it here. So it has come in here. Now nothing has executed. So we'll come back to this storage explorer and do a refresh. So we don't have anything. Last log was in 23 February. So what I do is now I do an F10. So jump. So it does execute the activity function and it comes back here. Technically, it should come in here, but it came to this one. That's what I was telling, that event sourcing. It knows that whether it has executed that function or not. Let's do a refresh, you see that? So it executed hello London, right? So it received this input and then it executed one of this thing. Now it went into the second one, hello London and hello Seattle. So you can see this Seattle. Now if I do continue, I do an F10, and what it does is it executes another function and again it comes back to this. So if you go and do a refresh on this, you see that, come in here. So first is it received that input. So hello London, then hello Seattle, hello Tokyo. So it maintains the state till which portion it has executed, and then it gives the entire output. So it executes for the third time, and then it will not come. You see that? Now you understand why the table storage or the storage account is pretty important for that, because it maintains the state till what level we have executed. What was the input which you have sent? See, it came like this, like a 0, 1, 2. Okay, task schedule IDs also. So you can see that the task schedule IDs, like let's come back and check that. So Tokyo was 1, Seattle and London. Let's see that. When Tokyo input has come, the task schedule ID was 0. When Seattle, the second input, the ID is 1. When the London, it is the ID is 2. And is that what? No, there is more in the queue. So if I come in here, what was the name of this one? Test hub name. So test hub. Okay, here you can see that test hub control. These queue messages are the control messages. That means the orchestrator, the durable function, it passes the messages onto this queue. So whenever we pass the message onto the queue, that triggers another function. This is how the mechanism it uses internally. When it completes one of the Azure function, it passes a message or drops in a message in this queue so that the other Azure function will pick up this message and execute it. So now I think we understood a little bit deep into this. And another important thing is it uses some of these leases and other things, but I'm just giving you extra information, folks, but please don't touch anything here. You might break the entire application. I just want to give you more information, what happens under the hood. So that's these things. We need to revisit this in this storage account once we deploy. Okay, at least let's do a first cut deployment now. Anyway, we are going to change the shape of this Azure function in next 30 minutes until whatever the time we have. Until then, let's go ahead. What is the function name? I call it as test. Come, let's do the deployment. Right mouse click on that and click on publish. And you want to deploy it to Azure. And this one. Okay, it recognizes. So React wrap. We'll create a new one. Okay, so let's give the name of the Azure function as test. It was dev. This is test. And the resource group is I will use this March one. And the plan type, as I was mentioning, when it is consumption plan, that's a pure serverless. You're not booking any server upfront, any hardware or any compute, you're not booking upfront. If it is a premium or app service, that means you're booking your compute upfront. So let's use East US. And it has rightly picked up, or this one, V1, that's a storage account. Let's ensure that, yep, that's a V1. So the storage account, guys, again, see that at this point of time in containers, there's nothing in here. I did refresh. Chalo. Now let's come back to this one. I just click on create. It creates those resources. Now again, there will be some more deep dive into that storage account to see that when we create this Azure function, why does it need this storage account? We'll see that. Shakir or Misbah, just do a time check. If I mean,
Yeah.
yeah, I
So the
mean,
next
just
session is at 12:30, so you have some time.
okay. Then
I will do that.
that's what I need. I need extra time. Cool.
Yeah. So you could probably wrap up like 10 minutes before the next session begins. So that's around
Oh,
12.
okay, so that's yours. Time is
There's uh, there's a
12:30.
question.
Yeah, 12:30 minutes. I can stop at 12:50 India time.
Yeah.
Mm.
So so that's
40
12:15.
minutes.
And yeah, around so it's 11:50. It's around 12 here. So
Yeah,
that must be 12:30 already on your time, right? So
yeah,
it's
12:30 my
yeah.
time. So still have 40 minutes,
So
right?
you have 30 minutes more.
30
So
minutes more.
30 minutes, but like let's say you can finish in 20 minutes, next 20 minutes, so that
Mhm.
I'll need another 10 minutes maybe for the next speaker so to join in and set up.
ठीक है,
So
ठीक है,
yeah.
cool.
So there is a question that's been posted up. So that sort of says that do these queued messages time out which you have used in Azure table storage?
Uh, queue messages timeout, no, because even if it times out, um, let me step back. What is the question?
So the question is like all these queued messages that you're sort of showing, like,
Mhm.
are these being like, do they queued out when you are using this Azure table storage component? So
Oh
that's
yes, they will be queued out because this is I'm just showing what is happening under the hoods because we don't drop any message in these queues. You see that we don't drop any messages in the queue. Even if you refresh, that will not be available. So it is taken care by the durable function framework because that the durable function maintains these queues and drops the messages. That means it is giving an indication or a signal to the next activity function to start. So it uses these control messages to kick in the another function.
okay.
Uh, Azure durable function control. This is the control queue. So what happens is this, it internally maintains this one. See this as Azure durable function control queue messages. So you can get deeper into this one. Okay, so it drops in the messages in these control queues so that it is an indication to the next function to kick in. So it maintains that internally. So even if it is timing out, just for even if it is timing out, uh, it is the duty of the Azure durable function to send another control message. They will have their own framework, isn't it? They would have decided what should happen. Because if I drop a message in any queue, it will be my duty that the Azure function, which is targeted to pick up the message, will pick it up. So if it is not picking up, then that's a bigger issue which I need to take care. But here the durable function, Azure durable function guarantees that it will execute all the activity function. And it maintains the state as an similar to the event sourcing, it maintains the state in the table, Azure table function. And once it receives the message, we have seen that it will not go and hit that particular method, but it jumps to the other method. How does it know? It knows because of the state it maintains in that blobs table storage. The table storage gives it how much function has been executed. Then durable function definitely knows that the step one of this flow has been executed. Now the step two Azure function should get triggered. So it drops a message there. So everything should be equally timed. Even if it goes out of the way, I think it will be handled. So guys, let's come back. So here there was only logs. Now you see this Azure Web Job Host, Azure Web Job Secrets, and app lease and leases. So let's dig deeper into it. So I'm just giving you an extra information, folks. Just understand this is like a keys of the kingdom. Like it might break if you don't use it properly. So this is the host.json that's coming in here. And let's go and see something else. I'll come back to this host. These are sync triggers. You'll see that sync triggers. And we'll come in to this secrets, where you will see that Azure function JSON. That's a and also host.json. So it has got the entire code hosted somewhere. So how do you know that? We'll dig deeper into that one. So we didn't you see this, the queues also we saw that. The queues also we saw that like a control 0, 0, control 1, control 2, and the work items. And you can see those tables getting created. So function, weather, utility, history, and the instances. Now let's go dig a little bit deeper into this one. Come into the Kudu console. We don't have Kudu now. Oh, we are in the storage account. I'm sorry. We are in the storage account. Let me do a refresh into this. So let me come back to this one. It's consumption plan. So let's go and go to this advanced one, and also let's see this. See into the app service editor. Let's see that what is available in the app service editor and what is available in the Kudu console. Again, this Kudu console is like a keys of the kingdom. Just please ensure that we use it. Okay, so see here we do ls or dir, whatever is your favorite command line tool, use it. And okay, I do cd site, and I do an ls, and I do cd dub root, and I do an ls. So you see that the function one, function allow, function start, and the bin and the host JSON, everything is here. That means even though it is a serverless. See, this is what exactly we see in our source code over here. If I come in into the host JSON, you see that the same has been hosted somewhere because this is a physical machine. If I come and type host name, so that gives me the name of this container. I don't know what it is, physical box or a virtual machine or a container, but definitely it is being hosted somewhere in some application, app service or website. It is hosted in some website. This is the proof that uh, what is happening under the hood is it has got this website. You see that the deployments, everything is being tracked. That's one important piece. And the other important piece is the web. Whoever is a command line guy, they can go and they can start playing in here. Or if you are a click guy like me, you can come in here and you can see that all these functions here, whether what type of function. This is an orchestrator, and this is an activity, and HTTP start is a starter function. So starter function is the one which kicks in the Azure function, and the starter function will do its basic jobs and then trigger this orchestrator function, and the orchestrator function will go and execute all the activity function. This is some of the other details which I want to do a deep dive. We did the deep dive in that. And let's see whether the application insights, let's not focus on application insights. Let's start building in this, some of the extra functionality, let's build in. So we started with Azure function, and we spoke about the Azure Durable Function, and we spoke what is the event sourcing, what is the task hub, where it maintains the state, how much function has been executed, and where it should start executing this one. So Shakir, just let me know if I have 10 minutes, then I'll start. I have 13 minutes. More?
So you have about 10 minutes.
13. Okay, cool. So
Yeah.
let's switch back to the other demo. This one which I did it. So here are a few other important points. So let's discuss that one. So whatever the uh, thing which we saw here, the names of these tables and other things, we said that test hub and other things. Can we change? Yes, we can definitely change. I think I will close this so that we can focus only on this piece. So we can definitely change. So under the extensions durable function, you can write the task hub name. So I changed this to 20 March 2022. Okay. So then I do a publish, right mouse click and publish. Let's publish this. Let's see what kind of tables it creates. And then we do some other deep dives. Let me go and delete that because we already deployed it. It will not take much time for us to deploy because these are the internals which I feel we need to know that. Based on that, we can properly strategize what should be our workflow, how it should execute. Let's wait. Let's wait. Come on, come on, come on, come on. Go. In the meanwhile, we'll come and see. Uh, Come back over here. We saw the tables. Let's go to the tables. If you see the table, it was the function whether utility test and what was in local is little bit, it will be a little bit different. Let me go and do another push into that. This is the fully baked in function. Okay, so let's push this. Let's publish this one. Okay, while it is publishing, we spoke about this point, like whatever the hub task hub name it creates here, the task hub names which we can modify. Where do we modify? We need to go to the host.json, and that's where we will change the name here, add durable task and task hub name. How do you know that? You can come in and search for this. Where did I search? Yeah, here. So under this, you need to have extensions, durable task, and hub name. So that's where you will go and update that one. That's one tip. And another important thing we need to verify is, let's come in here. Let's refresh. You see that? We can modify the task hub, whatever is the task hub, which it creates the history and instances that we can change it here in the host.json. That's another tip. And another tip is we'll see the startup function in a minute. And the starter function is the one which get hits first. So if you want to do some kind of pass in some kind of parameters, so you need to take that as an input here in this starter function, and we do typecast it to a DTO model and then pass it to this one. So that's what we are doing in here. And when it comes to the orchestrator function, this is where is very, very important, folks. So if you don't create this safe log, okay, if you don't create this safe log, what happens is it writes the same log again and again. See this, what is this? Azure Durable Context is one. Returns an instance of the logger that is replay safe, ensuring the logger. So what will happen? We will see that now. So if I comment this, and let's put a debugger over here. Let's put a debugger over here, and then we will execute it, and we'll see what will happen. So what happens is it again and again it writes, because in the previous instance we saw that when the Tokyo is executed, then it executes the Seattle, then it executes the London. If you don't have the safe logger, what will happen is the same message will get printed again and again. So what does that mean? So it didn't start anything. So we need to hit this Azure function, passing in the input. So which we already have. Let me go in here and let me kick in this weather utility starter. So when we kick in this weather utility starter, you see this logs over here. So do you see that it just retrieving the DTO from request? So that's this message we have retrieved. We didn't execute anything. So this is the first function, invoking get weather data. So I just click on continue. So it executes that piece of the workflow and again it comes there. So when it comes there, if you come and see that, it said that somewhere it says that invoking the weather data activity function and it completed. Now see this again, it is telling that retrieving the DTU from the request, which is not the true picture, isn't it? It has got the event sourcing. It doesn't do that, redo that piece of the functionality. It knows the state where it should execute. So now see that what is the pain point. The pain point is again, it's saying that retrieving the data and it is executing the weather data. And again, it says that I'm executing the Celsius to Fahrenheit. And next time when we come back here for the third time, again, it executes every bit and piece of the log, which is not the true picture of that because we are doing this debugger. That's the reason it is failing, but don't worry about it. So if I enable this logger, the safe logger, now let's re-execute this function. This time we'll not wait that much. We'll go a little fast, but now let me come and kick in the trigger here. Okay, so you see that the first in the workflow, the first function, it says that retrieving the DTU from the request. That's cool. And now it executes the first function, it's back. Now you see that in the logs, you don't see that messages again. So it says that retrieving the DTO and that's it. It's stopping. The get weather data is done. Now if you come in again, you go on continue. Now it says that it is executing the weather Celsius to Fahrenheit, but it didn't say that it is retrieving that DTO. That's only one message. So please use safe logger. So that will help you from a lot of these messages. The repeat messages, you don't need to go through those many repeat messages. Let's do. And you see that the new tables has been created. This is the name. So task up. That's one thing. And another important thing is why do we need to have this? Like to have the entire workflow, even if you throw some exception. Uh, okay. Even if we throw some exception, we are handling that exception. So you can see that how two inputs in success scenario as well as in negative scenario. Let's focus on those two. And then we can go on a Q&A session. Okay, that's the starter function. So let's kick in this workflow. So it executes the workflow. So it got the DTO and it executed the second function, Fahrenheit, and then it failed it. There should be a message, get comfort index. Okay, okay, I put in the code there, divided by 0, I'm sorry. I put in that divide by 0 inside that get comfort index. Weather weather report. This service activity function. Where is that? I put in here.
So just to give you a heads up, you can wrap up in a couple of minutes.
Yep, yep. So this is the one, folks. If you see that, here is the one which I'm injecting. What happens if there is some exception? So I already planted a bug or an exception in fact, I planted an exception. Shakir, I'll drop it in 2 minutes. Just wanted to show them how will be the output, the safe output, even if that workflow is blowing somewhere in between. So let's replicate that. You'll come and you'll see that triggers this workflow, and it's executing the workflow, and the divided by zero error will come in here, the divided by zero error. But if we can go, still we can get the output. So here, this is the input which we have sent, and in the output, we are saying the success is false. And we can give in some GUID and other things to get the proper data. Okay. Suppose if I remove this, 30 more seconds, I'll wrap it up. I will comment this, and if everything goes well, so we'll get the weather temperature, and we'll convert from Celsius to Fahrenheit and get the comfort index. So the entire workflow will run now. You'll see the different outputs. So this is a different output. You can, even though it is error, we are not failing. We are moving further. So let me click on this. It executes that workflow. Now we go here, and if we execute this, now you can see the difference between how we will formulate the successful thing. When if it is a success, we'll say success is true and give whatever is output. If it is failure, but just the don't give that exception message, but give the output something like this, where the success is false and the message is something you want to give the message. Okay, so that's it from my side. So any other queries?
Um, yeah, I think that's about it. I think it's been a great session so far. I think Swami, it was a very interactive one. Like interactive in the sense that you were able to be like more specific about the scenarios, the debugging issues, and then how we sort of come across issues in a typical scenario of of these
Production
functions.
production scenarios, right?
So also there is a question on how to expose a function. uh, I think that yeah, it's how to expose a function via an API in Azure. So it's a very, I think, generic one. So
Oh
you
yeah,
can
I mean, it's a generic, like you can write an API inside that Azure function and then expose it. That's like a leaner version. It doesn't have any of those controllers and those kind of mechanisms. It's just like the piece of code. Like you can have a dependency injection, the DB context ADO or Dapper. You can have those libraries aside and then expose this HTTP triggered methods in the Azure function. So those guys will hit the HTTP triggered methods, which uses this dependency injection of those libraries and get the data and spit it out. So they can ping me on Twitter. I can give the sample code which I created in my previous sessions. So anything else?
That's about it. Thank you so much, Swami.
Thanks, folks.
Yeah,